So I'll just briefly introduce our speakers. Dr. Carl Keane has been a lecturer in Department of Material Science and Engineering since 2015. Before joining MIT, Carl worked for 3 years as a programmer at Wolfram Research. They're the folks who make Mathematica and Wolfram Alpha. Also, Dr. Peter Barendse is a visiting lecturer who teaches a freshman advising seminar called Code Your GIRs. And he's working to bring weekly coding assignments to 802. And before joining MIT, Peter was also with Wolfram Alpha. So please join me in a warm welcome to Kyle and Peter.
Okie dokie. Hello, everybody. I will go, be prepared for that to get brighter. I forgot to turn this into colors that you all like better than I like. So, yes, so I will give you a big picture of what's about to happen, as well as your exit ramps. There's a good place somewhat near the beginning where you can leave if you want to, and I will let you know when that moment is. The first thing I'm going to do is talk about the people that are involved. And then I'm just going to show you what it is I'm going to talk about. And that's the moment after which you see everything I'm going to talk about that you can go, okay, I understand, and leave. Or you can stay and I'm going to get into the details about how I've made some of these things happen and what's possible in the coming months or so. So we're then going to go into a very kind of low-level introduction to what Wolfram is and what these tools are and how they can connect to MITx. And then we will get into widgets and things that go onto the web that hopefully make learning a little bit more enjoyable for students and a little bit more engaging and active. So I didn't want people to get scared, so I made a mathiness versus time plot. So you can know right now I'm talking about a chart and a graph. So there's a spike in mathiness, but the rest of the talk won't be very mathy, so don't panic if you see mathy bits. It's going to calm down after a little bit. And I just like to be upfront about things like that. So this is the very non-mathy bit. So these are the people that have made all of this stuff possible. We like to refer to ourselves collectively as the Interactive Materials Education Laboratory, and we work on projects that we hope make learning things like material science and physics and quantitative analysis a little bit more engaging and fun. And we are also trying to study that quantitatively. And we have been very, very lucky to get some sponsors and some organizations that we are very cooperative with and very grateful for their support. And we are currently working with the Course 8 physics folks, and we are actively looking for faculty who want to bring a little more exciting digital tools into their online courses. So if you are faculty, or if you know faculty, or if you're a student and you think that these things that you're about to see are cool, get in touch with us. The easiest way is to email imel@mit.edu. All right. So the that is not the big picture demonstration. That was I was showing somebody else something right in the middle of my presentation earlier. So the big picture is MITx, and I'll even go to the student version. So does anybody here not know what MITx is and what it can offer? All right, that's great. Then I will talk very quickly and not belabor any points. So MITx is an online course platform, and it lets you stick stuff onto a website where people from around the world can come interact with it. So you can stick regular HTML and have students read stuff. You can stick videos and have students watch stuff. You can stick some multiple choice questions and have students answer some things, and that's at least some level of interaction beyond watching a video or reading some text. And then there's two other little boxes right here, and they show that we can stick anything we want into MITx. So we can embed via an iframe something such as a link that has a student pop out and go over into the Wolfram cloud and get to work on inside of their own account and do some programming stuff. So there's other clever ways that I can embed this inside of it, but for the sake of simplicity, we can now pop them over into an environment where they can write code and see results, and then jump back over into MITx. And then there's some other things that I'm going to show you that we can embed inside of these courses. And then the last box is a way to give students the ability to do some stuff, maybe even submit some code, but I'll show you a bunch of other really cool stuff. And then get back a result, which is we can analyze their code and we can look at their results. So if we have students doing some coding, we can have them bring their results back, stick it into what seems like natively MITx, and get back a grade. And the rest of the talk will be switching out these boxes with some other really cool things that things that I think are very cool, that you probably don't know were possible. So that's the big picture. I'm going to just be showing stuff embedded inside of MITx. So this is the moment where if you say, oh dang, I didn't realize I was going to see a bunch of MITx stuff, then you can gracefully leave and I will not have my feelings hurt in any way. But, all right, everyone's sticking it out, good. So now into the weeds. So Wolfram is a company that's been around for about 30 years, and they started with physicists who didn't want to do algebra, and so they made a computer software that would do algebra for them. And the system has now grown into a giant, full, complex computing environment. And something that your students will know is Wolfram Alpha, which allows them to ask things like, solve this calculus problem for me, and it shows them step by step how to solve it. I will sidestep the ethical and moral, philosophical quandaries about whether it's good or bad to give students that type of access to information. But that is what it is. It's a tool that does that. And yeah, so almost every student at MIT will know of Wolfram Alpha. And they will say, oh yeah, I used it in high school to do calculus. And I think for some it is a very good tool, and for others they may become dependent on it. But for the purposes of this moment, I'm avoiding that whole thing. So I can tell it to, plot sine x times cosine of y. Great. So in human language, I can type this thing, and it gives me back a very concrete result. So this is Wolfram Alpha. It's a thing that can do mathy things, correct spelling, do all sorts of funny stuff. It knows what I'm asking for, and it knows how to plot it. It's also the backend for Apple's Siri. So if you ask Siri what the highest mountain in the United States is, it ends up sending a request over to Wolfram Alpha and getting back the results. So this is a big public-facing thing that Wolfram creates. It is very useful, especially for students who don't have access to tutors. So it can become an automated smart tutor that helps them practice. And then there is Mathematica, which I will assume 30% of you know about, and 60% of you have either never heard of it or only know it by name. And I should have gotten rid of these things. So this little chunk right here is a piece of code. This little chunk right here is a piece of code. This one says find the derivative. So this is the mathy bit. You remember I had on the slide, it said there was a little peek of local mathy stuff. So it can take a partial derivative, it can solve a differential equation, and it has some very complex result that's a Bessel J. If I don't know what a Bessel J is, I can ask the system to plot Bessel J, and then I can learn that it's this funny oscillating, decaying thing. And I can even make a funny little widget that lets me come and interactively change the order of my Bessel function to understand what that means a little bit more physically, a little bit more intuitively. So these are very small little snippets of code, and this is what most students at MIT will have used Mathematica for. And it's really good at this. I got through my whole bachelor's using it as a really fancy calculator that let me explore solutions to mathematical equations. It also does an incredible, huge amount of other stuff, but I'm trying to build off of what you probably have as a familiar perspective on what Mathematica is. So this thing that I'm working in is a notebook. And Wolfram patented notebooks 30 years ago to protect from patent trolls. And then Jupyter and IPython decided that they wanted it for Python, which I understand completely, and Julia has a beautiful notebook system. And so there's all of these notebook computing environments, and Mathematica is just one of those. So when I run a small piece of code, I get back a result. If I want to annotate this thing by writing text, I can write text right inside of this thing, so it's like a Microsoft Word document, but I can throw code and get results out. As of the latest version of Mathematica, there's something which is kind of cool, which is you can write Python code and have it hit a Python interpreter and get back the results in native Wolfram data structures. So I'm not doing anything overly Python-esque, but I'm adding two numbers, and that's actually sending the result over to Python and getting the result back. So the 30-year-old notebook of Wolfram can now be used to code inside of Python, which I'm very, very excited about, because there's times both are really useful tools. All right, so, and the next little bit is what I showed you earlier, was I had a student who could come over here and code. So this is inside of a web browser, and it's not a complicated thing because it just does what it's supposed to do. It's a Mathematica notebook, but it's running in a web browser, so you don't have to have any software installed. So this is allowing global learners who have bandwidth to be able to compute without having to completely bog down their hardware. So I won't belabor that. That's just a thing that now exists, and it does more than math. But I only have so much time, and I want to get through these bits. All right. So the one last component. So there was 4 components I wanted to talk about. The last one is the Wolfram Cloud. So right here, I'm writing some Wolfram language code and running it inside of Mathematica, and I get my fancy little widget. And then if I come down and I use a function called cloud deploy, I run that, and it takes my widget and it throws it onto a server that I can then give a link to any student in the world who can go visit that URL and have access to my fancy widget and explore Bessel functions. So
this is in JavaScript.
This is running native on the web. Yeah. So this is just a regular HTML5 page with JavaScript. So those are the constituent parts. We have MITx, we have Wolfram, Mathematica Online, and the Wolfram Cloud. So this is a moment when I feel like I've talked too long in a boring way. So I had some fun with haikus. And so I say, if your mind is wandering, then choose to come back and count syllables with me. So I believe that's a 757. The part in the middle doesn't have anything. Wouldn't it be nice to have some of these Wolfram tools in MITx? That's just the logical flow of the talk. And we certainly thought it so, and hope you agree your students can benefit. So I like to change my mind. And then, so yeah, just in case you were worried that that's going to happen again, I promise it's not. That was a direct delta, and haiku-iness over time is, it's past. So, all right. So if at the end of this talk you see some things and you say, ah, cool, that would go really well in my class, you're going to go to this URL or email me or email imel@mit.edu. And at this URL, I am compiling a bunch of resources for being able to use these tools. So the very first one is, oh, you showed some cool stuff. And the truth is that I spent, it's about 20 minutes of making sure MITx knows how to speak to Wolfram. And so I put together a guide that's like overly meticulously detailed for anybody who wants to do this same thing. I have screenshots and arrows telling you where to look and what options to change in your setting. And it's about 20 steps. And it's just, if you work in MITx Studio, you know that you have to go through a lot of menus sometimes to change some of the advanced settings. But if you want to do it, I am compiling resources. And if you tell me the things that you want to do, then I will prioritize resources to help you. So that's an important URL. All right. So those are the more dry bits. And now I get excited because I'm going to show you code. And if you're scared of code, then don't look at the code and just listen to my words. And if you like code, then there's going to be code there. And I'm going to go back and forth between code and then actual living things. There's two things that I want you to gain from this. One is the code is not that intimidating, hopefully. And two is I want you to understand what things are possible. So if you walk away thinking, yeah, I could probably do that, and some of that stuff was nifty, then I have done my job. So let's set clear expectations. I'm not trying to convert you in any way, just to think, yeah, that's a possibility. So we did this one before. We have a plot of a Bessel J function. And if I come and show you my favorite plot, I'm a fan of repetition. I don't know why. It's just been with me for a long time. So this is my favorite little thing. And then I'm going to do the same cloud deploy that I did earlier. So it's one line of code. And then I do one more line of code, which is this function called embed code, which tells me, here's some code for you to embed this in your MITx course. So I'm going to copy this code and jump over into MITx. And now I'm in the studio where I can edit my course. And I'll come to my iframe thing, and I'll edit it, and I will just take that thing that Mathematica gave me, and I will paste it right in there, and come down and save, and I instantly have my little widget, both for me to play with as an instructor inside of my course, but then also for my students to come to this iframe tab and play with it inside of their course. So this is the easiest thing to do if you have something interesting and interactive and you don't want to grade the students for doing it, you just want them to have access to it, then we can do this in what was 3 lines of code. I mean, the interactive thing may take more lines of code, but you build the interactive thing, you stick it on the cloud, and then you embed it in your course. And if you need inspiration, so I got a really nice suggestion from somebody in biology about one that they thought was interesting. And so I'm just going to go to the site demonstrations.wolfram.com. which is a collection of what is now over 11,000 of these little interactive widgets that teach everything from biology to art to physics to everything you can expect. So if I jump onto this one, which the biologist thought would be very interesting for their biochemistry course, I can come download the file, because all of this stuff is open code. So there's all of the code, and it's a bit complex for me to try to parse right now. They put a lot of effort into this one. But I can simply run it and get my own version of this interactive thing that lets me explore this process. And now I'm happy with this, and I want to give it to my students on MITx. So I do the same 3 steps. I come to my manipulate, and I say the widget that I want to share is that whole manipulate. And then I cloud deploy my widget. I share it with the world. Let me zoom in so that that font gets bigger. If it will cooperate. There we go. Too much zoom. All right, so I'm cloud deploying my widget, and I'm going to put it at the same place so that the MITx students can get to it. And that is now sitting inside of my course. So I switched it out with the previous widget. So now my students can all come and explore. Whoop. That was very mysterious. I'm going to rerun. What? Do you think that was a caching thing?
Do the embed code thing?
I can, but it should be exactly the same embed code.
Oh, you don't need to do that again.
It was there, and then it disappeared when I clicked on it.
There we go.
Oh, all right.
Something.
I think it's a browser caching thing so that it's fast. It tries to save a copy of it.
The cloud has different initialization than the demonstrations projects.
All right. All right. It was just working a minute ago, though. I'll refresh and cross my fingers. Right? Because there it is. All right. All right, so everything in the cloud takes a moment to matriculate through the whole system. But so now any interactive thing I can just throw up onto the cloud and embed in the course and give it a minute to matriculate through all the different browser caches and server backups. So that's another ungraded way to just make your MITx courses a little bit more interesting. The other thing is the one that I showed you. So I just want to make a cloud object and have it be a link that's going to push students over to code somewhere. I could also just directly drop that link into MITx. The ability to code in a little box inside of MITx is in development right now. So that will be coming hopefully by the fall. So now I've replaced that object with a tool. Should give it a moment to relax. There we go. All right, I should not rush the cloud. All right, so now it's a link, and if the student clicks on it, then they are brought to an online place where they can go code. And within the next few months, you should be able to have your students code right inside of here. There's one small thing that still needs to get worked out for that. Okay. All right, so that's Ungrade It, just trying to add something a little more fun and interactive onto your site without having to become a JavaScript HTML master. The next part is, but I want students to do a thing and then be graded on whether they did the thing right. So with the previous ones, what you can do is embed multiple choice questions, native MITx multiple choice questions inside of there and ask them about the widget that they played with. But we can also now grade things directly from our widgets that we are building in the Wolfram language. And this is the framework that you read about in the talk description. So I won't get too detailed in the code. I'm just adding a variable, which is this thing, which is student value. And then this is just my same interactive BesselJ function. And then I have to define a grading criteria. So what I say is, if when the student tries to submit their grade, if the current value of this slider is between 5 and 6, then I want to give them credit, and otherwise I don't want to give them credit. So I'll run that, and then show you that I can test it locally. So if I come and move my slider far away from 5 and 6, it gives me a 0 results. And if I come, it's a little bit small, sorry, I'm going to type in 5.5 and then ask the system to grade me, it gives me a 1. So now I can put an ability to have students place this thing within a certain range and get credit for what they did. To push that onto MITx, you just follow an incantation, and you never have to change this little bit. And I will even kind of obscure this away so that you won't have to worry about it. You take your widget and you stick it into there, and then you push it up onto the cloud. And the only thing we're doing on the cloud is we are loading my package that I published for everyone to use. And then we're using a thing called launch notebook, which is a function that takes care of all the work for you. So I'm launching that to this 5th tab over here. So I'm going to refresh, and we should see my BesselJ. And if I drag my slider to the right place, for instance, if I had asked them to find a sweet spot where the frequency is something in particular, then they can submit and get a score based on where the slider is on their little widget. The next little widget, so that's the kind of the simplest one, is you have a slider and you have to put in at a certain value. Very quickly, with not that much more code, I can make so that much code, and I have some cute styling on there. I can make something that asks the student to draw an arrow to the zeros of this curve. So they should draw an arrow to there, or there, or there. They get to choose one of the zeros. If they draw down to a minimum or they draw to a maximum, they shouldn't get credit. And so my grading procedure, it may look arcane because you're just seeing it for the first time, but I promise it's not that hard to get around once you start to play with it, is if the student's x position, divide it by pi or 2 pi, has a fractional part that's less than 0.5, or then it's within some certain range of the minimum. And then I also need to make sure that the y value is within some range. So all I'm doing is I'm drawing a square around each 0 of my sine function, and the student has to drop it inside of that 0 in order to get credit. So I can test this one live as well. So I'll redefine that. So it's a 0 right now because I'm not at a 0 of the function. If I come, drop my thing there, then it's a 1. And I can develop this locally, and then when I'm happy, I'm going to push it to the cloud. And here I'll prove that it is, in fact, robust to issues of pi versus 2 pi. Oh, no. Maybe I'm not within the tolerance. All right, so I have to be really precise, and you can choose how precise you need the students to be. So this is that thing that you don't ever need to change. This is exactly the same code, and I throw that up onto the web, and then I come to my course, and I tell my students to go explore the zeros of the sine function. And they have to come, it's not done. Oh, okay, all right, it's a funny little dynamic. So they have to come tell it where to draw this arrow. And then they can submit to get the same score, and that score gets injected back into MITx. I will very quickly show, because I cannot show you everything that it will do. I will do a super fast. It can do all of these other funny things, so checkboxes and sliders, and even color selectors, so that you can have the students pick a color within a range that they like, or two-dimensional sliders, or buttons, or pop-up menus. So any type of control object you can embed inside of your widgets. And you can even have them come and draw something if they want to. And this is all of the code to produce a little drawing app that lets your students come draw something. So you can tell them to sketch what they think is the sine of x, and you can grade it based on the actual curve that they've drawn. And I'll show you an example of data grading in a moment. So there's another thing that I find kind of helpful for 2 reasons. So this is, if a student comes to this page on my MITx course, I can give them a point of credit. And I can either do that for their actual score, or I can do it just to track what they're up to. So I can figure out when my students are doing each part of my MITx course. So I'm just verifying that this is actually coming from MITx, and then I'm sending a grade of 1 into the system, and then I'm just sending the student to Google, because maybe I just want to ask them to go Google something, and I want to make sure that they actually did it. So I'm on the same page. If I refresh, then we should end up with this, which is a warning because I'm in Edge. And it tells me you have to go to another page to view this thing because there's security issues. And I have my proof that it was actually the thing that was sent from MITx by forcing it into the little Google search box. So now I can give credit or track what students are up to inside of my course using this fairly simple little chunk of code. I think it's fairly simple. Another thing that you can do is you can create, there's this really robust web interface framework that you can do on these server-side apps that Mathematica lets you spit code up onto. So I'm just going to ask the student to come and insert their own grade, and then I'm going to submit that grade onto MITx for them. So this is same page, refresh, because now I've stuck a new app at that location. We'll see if my browser cache will catch up to me. Nope. Oh, sorry. I also need to run this one. That was my fault. So now I've given them a thing, and this looks a lot like the little Mathematica native widgets. But this is actually JavaScript running in the browser as an iframe. And so they can come and give themselves a score of 7.13. And they submit, and then I get a confirmation message back just for my own debugging purposes, which says, all right, the student's score has gone to 7.13. If I refresh the page one more time, you'll see their current grade right there, update, to reflect that operation that just happened. So now their grade is in fact 7.13. So of course students won't come pick their own grades, but you can have that be anything that you want in order to assess what they're up to. All right. Let's see. All right, I'm going to skip one thing and then. Yeah, all of those fun interactive things work on the web. I won't show that. This one I think is pretty cool, so I am going to show this real quick. This is noisy data. So let's say I want students to go out and try to draw a sine wave, and then I want to find a measure of how good they did. So I'm going to export some noisy data that looks kind of like that. And then I'm going to make some good data, which is a nice pure sine wave. And then I can create a score, which is based on the sum of residuals. So looking at the difference. So if I come up here and make this. Oh. Even noisier data. And I come down here and calculate the score, their grade should go down. Did I not run something I should have run? There you go. So now I can actually have the students draw things with that little widget, and I can grade based on how good their drawing was. And the other, I should skip these. All right. I'll skip these things. I'll say them in words. So another thing that you can do is you can have the, and Peter's going to take the mic in a moment and tell you more about these fun things. So you can have students input the name of an animal and return a picture of that animal, or grade whether or not they knew the official name for the thing that you asked them. So there's a lot of really cool stuff that Peter's about to show, including pictures of kangaroos. And I'll skip that, and I'll skip that, and students will be able to code soon enough. And now we're going to switch over to Peter, who's going to show some of the, so this was like the guts of the system, and Peter's kind of our advanced R&D guy, so he's pushing assessments out into the future.
Can we ask you some questions, though?
Yeah, it was, as we switch, definitely.
Have you thought about writing some wrappers to help authoring for people who want to import to do work like this, but don't want to master the Wolfram language?
What type of thing would they? I mean, I have about 300 lines of code that take care of all the MITx stuff. So there is a lot of wrappers already there. So I don't know which one you would want.
Make it into a button or something? Is that what you mean?
I'm just wondering, kind of I'm not sure how intimidated somebody who would be who's never seen the language before.
We could take a poll. On a scale of 0 to 10, how many of you are intimidated by what you just saw? If you're really intimidated, say 10. If you're not intimidated, say 0. 1, 2, 3, how intimidated are you?
4.
All right.
Well, the average of what I heard was 4. So I feel like I did a good job.
Okay.
I don't know. Yeah, it would be, if there's things that were intimidating, ask me and I'll help simplify. Yeah.
Do people around the world have access via online to Wolfram mathematics?
So all the MIT students have it through a site license.
Right.
MITx students, there is a new partnership involved.
A
So
person anywhere around the world, anybody on the internet, how do they get access to mathematics other than buying it?
If they are enrolled in an MITx
I'm not
course,
saying around the world, no, not enrolled, just anybody.
well, they find it. They either try to get a scholarship
Is
or
there a
they.
free?
There's a
online
free
version of
version
Mathematica?
that you can use that doesn't save the file. There is free on the Raspberry Pi, so if you can buy a Raspberry Pi for $5, you get Mathematica for free.
Right, that's a huge
Yeah,
It's a full Mathematica.
full Mathematica, yeah. And
Some things are not there. It's a slightly older version.
it's one version behind,
But
but
you're basically just doing the Linux download and it's included.
yeah.
And
Yeah.
it's also there's also free on the cloud, right? You can use the cloud for free as long
use
as
the
you don't.
cloud as long as you don't. You can't save files.
You can't use it.
Yeah.
Is that what you were talking about?
Yeah.
Okay.
But all right, so I'm gonna let Peter do things. Save those questions, and I'll talk more about those. I can stay after 4 o'clock, but I want him to show his stuff.
Okay. Thanks for coming. I'm going to talk about grading because Kyle's already showed you how you can take any type of content, be it text or clicks or a bunch of code from the students, and apply some grading function and return it through MITx. So I am just going to work just in the notebook, and you can trust that any of these grading functions or techniques that I'm showing you could easily be implemented in MITx. So I've been teaching for a long time, but I don't have a lot of knowledge of the sort of the standard nomenclature and such of some of the things I'm going to be talking about. So please correct me or excuse me. So I'm going to try to start out with the most basic kinds of interactions, the simplest kinds of data that we could grade, and then I'll try to get more complicated. And ultimately, what we hope to work with is to be able to analyze and use in grading all the steps that a student takes. And we have the technology to do that. We actually have a framework that records every keystroke and every time the student uses help, every time the student evaluates something, what errors were generated, and everything, which is great for analysis. But when it comes to grading, there's obviously some tricky issues there. So I'm going to get to that in the end. But so I've been using Mathematica to grade for quite a while. And I first started out just with having it help me to grade. So the first thing I started out doing was something like this.
Can you zoom just a bit?
Yep. Okay. So the students, I assigned students to go to the Wolfram Cloud and do some sort of, this was maybe 5 years ago, do some sort of task, and it would all get saved in my cloud somewhere. And then I would look at all their answers all together, and I'd put them in some sort of grid with a bunch of checkboxes so that I could easily sort of go down and say, yes, no, 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 no. And so that sort of helped speed things along and allowed them to do work online. So that's not automatic, though. What I've been doing is some sort of combination of automatic grading and hand grading, and I've gotten pretty good at combining them, and I'll get to that in a little bit. But the next most simplest thing that we can talk about is the interpreters that Kyle mentioned. So Kyle mentioned that there's this function interpreter, and you tell it what kind of interpreter you want, so an animal interpreter, and you can give it a text, and it'll understand what sort of animal you're looking for. During any of these, if somebody wants me to try something, just yell it out. Just say, what if you type this? Okay, and we'll see what happens. It works. These work very good, and they actually already work a lot better than, I don't know if you've heard of My Math Lab, but there's that and other similar products are used a lot at colleges. I tutor at Bunker Hill Community College, and all the students there have to use My Math Lab, and after a few years, I've gotten to know what sorts of things you can and cannot enter in My Math Lab, and it drives students bonkers. But so it's already easy to interpret, say, numbers. So if you have pi plus 12, if the student writes it like this, the interpreter will know it's 12 plus pi. And then this is a Mathematica object that I could then ask for the numerical value of, or whatever I wanted. You could give this interpreter a second argument to say, I'm looking for a quantity. And then it'll know that this is you probably can't see that, but it says unit meters per second squared. So it interpreted that unit to the correct units. If I didn't interpret it, if I didn't put quantity there, I would think it was just some mathematical expression with m and s as variables. Another example, right? Congo returns the Democratic Republic of Congo, the country. And then if I tell it I want a river, well, then it gives me a Congo, the river. These things, believe it or not, are just code prettied up a little bit. I can copy and paste them and ask other questions about them, and it all. It's just sort of a little packaged piece of code that contains other things. That's what that yellow thing is. So I can ask it the outflow. Okay. So we talked about Wolfram Alpha. It's the website where you type in stuff in English and it analyzes what you say and figures out the answer. Wolfram Alpha is also built into Mathematica, not surprising. So there's a function here that if I say Wolfram Alpha, let's do a very simple query. I got to keep track of the time too. Could someone let me know when it's like 5 minutes left? Sure.
I think my cell phone is right.
Okay. Yeah. Oh, I should just hurry up. Okay. So Wolfram Alpha can interpret things of all kinds of types, and it's pretty impressive what it can do. So if I type in this text, acceleration of 5Gs, it will return exactly that. So the number 5 times g, the standard acceleration due to gravity. And then you can continue to compute with that. Like you can compare units, like these 2 units, and just say, are these equal? This many kilogram meters per second squared, and this 2 foot-pounds of force? And it will do the units and just compare them and say, yes, that's a correct answer. So a grade function I could write would just be take the input, let Wolfram Alpha interpret it and get a result, and then see if it's equal to 5Gs. So let's do that. So if I give it 5Gs of acceleration, it says that's a correct answer. If I say 5.0000 Gs with a capital G, okay, it'll take that. I can even do square root of 25 Gs of acceleration. True. I can even give it I can replace Gs with 9.80665 meters per second squared. Although, so if I do a little bit off in the 5th decimal place, it'll no longer think it's correct, right? So that's the numerical accuracy, but you can always change that as well. 5G doesn't quite work because that's 5 grams. Okay, so it's not perfect, of course. Now, I'm going to tell you what we've been doing in 802 this spring. So here's a question from 802 that we actually assigned, and I'm going to show you how I actually graded it. So this is a Helmholtz coil, and you're going to ask, there's current circling around, same direction, 2 coils, their distances and such. And here's what you're asked. Calculate the z component of the magnetic field along the z-axis. So what is the field along the z-axis there? And then plot the z component and the derivative and the second derivative. And then another part, at what values of the first z derivative. Okay, so they're supposed to, in our scaffolded notebook, which we call a coset, they're supposed to enter some code, do some evaluations, figure out what these answers are, make the plots, and then say submit. So they submit a whole bunch of stuff. And that would take a human a long time to grade. What I'm going to do, though, what I've done is use something called pattern matching. So it's something similar to regular expressions, if you know that, but it works specifically on Wolfram language expressions. So what I'm doing here is I'm just saying, look for these patterns in their answer. Okay? They should have to use a dot product of some field with some z vector just in the z direction. They should have had to use find maximum to find that maximum in part 4. They should at some point have gotten a number which is equal to this number. That is the answer to part 4. They should have added some things together. They should have done this and that, etc. They should have plotted some things. And each one of these patterns gives a point. And so the automatic grader finds all the patterns they have, and if they get a sufficient number of points, so this should be, well, they should have gotten one of these, so they should have had at least 5, and then a 5, and then one of these. Okay, so at least 15. And then all the students that got 15 or greater pass. And then the students that got less, I will typically look more deeply into it. So I'll hand grade a few. And then maybe I'll realize, oh, I forgot to do this, so then I'll run it all again. But there's always a few that, they submitted it in some crazy format, and it just wasn't at all what we were expecting, but they did do it right, if you think about it. So that's always a problem. But in the future, once students get used to this, I think we can expect them to do it the right way, right? We don't, if they leave their homework outside the door of the professor's office, they don't get credit for that, right?
You're at about 5 minutes.
Okay, thank you. There's another thing that we can use to get more interesting information from what they've submitted, which is to run what they've submitted. Okay, so this is a dangerous thing to do, because if the code that they wrote crashed their computer and you run it, it'll also crash your computer, right? And then that'll be harder to get back to the grading. You have to restart everything and whatever. But it allows us to do some interesting stuff. So I called it a seductive spell that leads to the dark side, because what it does is it resurrects a student's code, right? And that's what Anakin wanted to do to his mother. So that's why it leads to the dark side. But what we can do when we do that is we can ask, well, did their code crash? Did it hang? Did it run? How long did it take to run? Did their plot actually plot something? And I should have written another question there. I meant to ask something else. But anyway, so two-expression is a dangerous thing to use. It's not allowed to be used in any production code at Wolfram. Okay, machine learning. I really don't have much time at all. But what I've done here, what I would explain to you, is I've made some fake code, some fake data from the students. So let's say each of these are their what they got on a number of problems, and then these are some grades that they got in total. So say I hand graded some students, and now I want to teach the computer how to grade it like I do. This is very philosophically dubious, as you probably thought, but again, it can be combined in sort of a soft way with maybe other types of grading. So what I did here is I can just take all this data and just throw it into this one function, predict, and it makes a predictor function. And so that predictor function is predicting their grade from their original. And so I wouldn't do this to actually give students grades, but what you can do here is you can find the most significant problems and use that for a sort of, what do we call it, item analysis or item response theory to pick out the questions that you should use again and the ones that really didn't help that you should toss out. So it can give you this whole report and all this other stuff. Well, I really don't have much time to talk about what I wanted to talk about is where we'd like to go when it comes to getting all the student data, which I mentioned before. Now, we're still in the process of changing this, but we have a lot of great ideas that I talk about here to how this would benefit. So let me just talk about some benefits of accessing all those grades to all that data for each student. So teachers could quickly see where students are getting stuck, right? And we're working on a nice visualization to allow a teacher to see what the work a student did in time and see what's happening with the student. Students have vastly different coding abilities. This is a problem because high school students aren't required to learn how to code, and yet many MIT students do. So this is something we've dealt with, and anyway, it's an issue. It makes it a lot harder for students to cheat on homework for the obvious reason. They'd have to fake a whole timeline of things, and there's many other unknown benefits that data would yield because that's the whole purpose of doing data analysis. But of course, there's some issues which I'll just leave up because I've run out of time. But I'd love to hear your questions.
few Q&A, and if people just need to leave, just as we leave off to the side. Does that sound good?
And I think so. So Pete has to run to his car fairly soon. So if you have Pete questions, you should ask Pete his questions, and I can stay later.
Yes.
So I teach a freshman, sophomore level discrete math class, and the large cost for us is grading proofs. We're not interested in teaching a formal proof system,
Right.
which is way too much overhead and is not really the way mathematicians and professionals think about proving things anymore. So we are looking at students writing in natural language and, explaining what's going on. And the only way that we've found that we can grade those is to hire an army of graders who don't do that good a job, by the way.
Yeah.
So that's been a long-standing challenge to get a grip on, and I have not found anybody who has gotten a grip on it. I wonder if you care to comment.
That sounds like a horribly tough problem, but my first thought was you could use a program to weed out the ones that are definitely wrong and maybe ones that are definitely correct, and just at least save some work.
The ones that are definitely wrong are not the issue. It's the issue of ones that are sort of half right.
Right, yeah.
You
There's
did
some
some
sort of-
automatic proof generation stuff, right?
Yeah, I can talk about that now. Yeah, we're working on automated geometry proofs, like high school geometry that produce, you've given a statement, will produce the proof in the language that high school students would use. Now, that doesn't mean that we could then check such a proof, right? That's a different task. But another thing that might be helpful is there's something called grammar rules, which is how Wolfram Alpha works. It's how Wolfram Alpha can understand sort of complicated sentence structures and replace different synonyms and different equivalent grammar structures. It's sort of built up from this thing called grammar rules, which is a function in Mathematica. And so that would be how I would probably try to catch the ones which are definitely correct because they did it exactly as we expected them to, basically. And then there will be others which, of course, are correct, but we don't know.
Do you have like the simplest example of a free form response that you would, like a good one, a medium one, and a bad one that we could play with over the summer?
I could supply them with you. I'm not going to try to generate one off the top of my head.
Okay. No, yeah. I mean, afterward, if you email those,
I have a
then we
lot
could.
of data.
Right. So yeah, it might be. It sounds like something fun to just spend a day trying to hack on.
I'd be delighted to work with you.
Yeah, that'd be fun.
He's a mathematical logician, so he's definitely
Yeah, that was my
That
PhD.
was my training once upon a time. Before your parents were born.